All right, let's use inverse trig functions to solve for measurements of angles. So what we have here is a right triangle. Notice this is a 90-degree angle, intersection of a vertical and horizontal line. And I'm going to label this angle theta 1, that's our Greek symbol, theta, which means angle, and theta 2. Notice that theta 1 is formed by this purple line and this purple line, okay? And notice that angle 2 is formed by this line in red that I'm highlighting and this line in red that's right here, okay? So let's work with angle 2 since it's highlighted. Well, when you have a right triangle, the longest side of the triangle is called the hypotenuse. And usually we just label it H. Okay, so remember, that is the side that is across from the 90-degree angle. It's the longest side of the triangle. Now, we're going to label the other two sides as either opposite or adjacent. So I'm going to erase theta 1 so we can focus on theta 2. I'm just arbitrarily starting with theta 2. And what you notice is this side over here is not one of the red lines that forms theta 2, angle 2. So it is opposite the angle. So if you look, it's way across, it's on the other side of the triangle from theta 2. So that side we're going to label adjacent. So this is I'm sorry, not adjacent, opposite. We're going to label O. O for opposite. It is opposite angle 2. Okay, and that means this side over here is A, and that means adjacent or next to. Adjacent. Okay, so the angle that you're talking about and solving for is always formed by the two lines that come together to form that angle. So we're going to use SOHCAHTOA to solve for this. If you haven't heard of SOHCAHTOA, it's just an acronym to help you remember the relationship between an angle and the ratio of the sides inside that angle. So we can use S is for sine, C a cosine, T is for tangent, and then OA and H for opposite, adjacent, hypotenuse. So let's figure out, let's do it a couple different ways. So I'm going to count the squares across the bottom, and this is 8 units long. So the opposite length is 8 units. The adjacent side is 6 units. And the hypotenuse is 10. Sometimes you'll know all three sides, sometimes you won't. We can use any two side lengths in a right triangle to solve for the angle. So let's use first the opposite side, right? Whoops. Sorry about that. Let's use the opposite side, which is 8 units long, and the adjacent side, which is 6 units long. So here we go. Now, if we have the opposite and the adjacent side, we'll be using, right, the tangent relationship, right, if we're using opposite and adjacent. So let's do it now. We'll say tangent of theta equals the ratio of opposite to adjacent. That's what TOA means, okay, tangent, opposite, adjacent. All right, so now, to solve for theta, right, we would actually need to take the inverse tangent of the tangent. Those are inverse operations. And in math, whatever you do to one side of the equation, you should do the other in order to keep the two sides equal. So what happens here is that on the left side of our equation, this reduces to theta. So we have this expression, theta is equal to inverse tangent of opposite over adjacent. You don't have to take this second step right here if you can go straight to this formula, right? And that's what we're going to use. So here we go. So theta is equal, in this case, theta 2 is equal to inverse tangent of the opposite side length, which is 8, over the adjacent side length, which is 6. Oops, and then you can just go to your calculator and say inverse tangent of 8 over 6. And you can type it in 1.33333, but you might as well just leave it as a fraction. Okay. And I'm going to use my computer over here. And I got 53.1 degrees. So I'm going to erase this. 53.1 degrees for theta 2. Now that was using inverse tangent. What if we wanted to use cosine, inverse cosine? Could we do it? Absolutely. So we could have said inverse cosine, right? I'm sorry, theta 2 is equal to inverse cosine of, now cosine uses adjacent over hypotenuse. I have to use SOHCAHTOA all the time. So it's a very useful acronym. So let's substitute theta 2 equals inverse cosine of the adjacent side 6 divided by the hypotenuse 10. So we 6 over 10. And then if we say inverse cosine of 6 over 10, I'm plugging it in on my computer. We should get the exact same answer, 53.1 degrees. And sure enough, we do. Now, that was using the adjacent and hypotenuse. What if we wanted to use sine? Let's highlight that relationship right here, opposite and hypotenuse. Well, the opposite is 8, and the hypotenuse is 10, all right? So let's write out our formula. So we could have said theta 2 is equal to inverse sine SOHCAHTOA, right? There we go. Let's substitute in inverse sine of the opposite side. Let's double check, make sure we're not going too fast. Opposite side 8 divided by the hypotenuse 10. 8 divided by 10. And then we should get 53.1 degrees yet again. So notice, you might be saying, why did he do it 3 different ways? Well, that's just to demonstrate it doesn't matter which sides of the triangle you use. You just have to be careful that when you're using tangent, you're using the opposite over the adjacent, right? You're using tangent, opposite over adjacent. When you're using cosine, you use the ratio of the adjacent side to the hypotenuse. And when you're using inverse sine, use the ratio of the opposite to the hypotenuse.